meant was the number that we had as the exponent if it was in factored form. So this thing is in factored form right now, and each of these factors has an exponent on it. Whatever that exponent is would be the order of that zero. So the minus 1, for instance, was an order 1 because the minus 1 comes from this factor right here. As you know, it's always opposite sign. So the exponent on that one was nothing, so we assume it to be a 1. On the order 2, on the 0 that was for the second bracket gives us, hold on, gives us this 2, and that is an order 2 because I'm raising that to the power of 2. The 1 is an order 3 because this x minus 1 is raised to the power of 3, and the minus 2, which comes from this bracket, is an order 4 because I'm raising that to the power of 4. Okay? So the other thing we noticed, and this is a quick review of the stuff we already did on Friday, is that they behave differently depending on whether the order was odd or even. So when it was a odd number, the fact is that the graph just went straight through the x-axis. So here's an example, I'm going to circle that in green, of an odd order. This is another odd order, right? Those graphs, the graph is actually just cutting straight through the x-axis. And what's happening also is that the sign is changing. It starts off being positive and ends up being negative. So on one side of the 0, it's above the x-axis. On the other side of the 0 is below the x-axis. So it changes sign from positive to negative or negative to positive as it goes through the x-axis. Same thing with the 1, same thing with the minus 1. But with the 2's, they're not changing sign. They start off being positive and end up being positive because they're just going to bounce on the x-axis. They just come down, touch the x-axis, and come right back up. Same thing is happening over here. Coming down, bouncing on the x-axis. It starts off being positive, ends up being positive. It's still above the x-axis. So that's how we distinguish between the even order zeros and the odd order zeros. Right? Very important distinction for us to make. All right. Now, I went through to some extent this whole thing here, although I kind of glossed over it to some degree because I wanted us to focus on the graphs themselves. I want us by the end of this class to have gone through all the graph examples that I have. And what we're going to be doing also is going to be filling in this table that we have down here, right? We're going to be asking the question, what's the degree of the function? What's the leading coefficient? What's the end behavior? What's the zeros? Zeros and x-intercepts are basically the same. I don't know why I make a distinction here. And what's the y-intercept? These are the questions that when you're trying to sketch a graph, and you're not using Desmos to do this, when you're trying to sketch a graph, you want to be asking all of these questions to help you to figure out what the graph looks like. Okay, I didn't get into the whole symmetry thing, which I hopefully at some point will touch on, but I'm going to leave that for now. I'm going to leave the whole symmetry thing for now. So we went through this function. We said it was a third degree function. And by the way, this is the same smartboard file that we had from Friday. So I'm just basically going over it again. And we said it was probably a third degree, which is the least it could be, the least possible. It could be a fifth degree, it could be a seventh degree, but we said it was at least 3 because of the fact it had 3 zeros. Right? That's the least it could be. And we also said that we could put this in factored form by putting x plus 5 for the minus 5, x minus 3 for the plus 3, and then x as well. And we could also probably figure out what the a was by plugging in some point that we knew. We chose to use a point minus 230. So that's this point right here, the minus 230. When we did that, this is all by way of review, the a worked out to be minus 1. So we could have written the function out as, well, I don't have it written out here, but we could have written the function out as, okay, what's happening with my, oh, here we go. We could have written the function out as y equals minus 1, x plus 5, x minus 3 times x. That would be the function itself. Put that on the other side. Okay, here we go. All right. Now, the other thing we asked is, where is it positive, where is it negative? Right? That's an important thing for us to answer. The function is positive when it's above the x-axis. So it starts off being above the x-axis anywhere from over here at minus infinity until you hit that minus 5, it's positive. Then anywhere from the 0 up to 3, it's also positive because it's above the x-axis. So we wrote that down. From minus infinity to minus 5, union with 0 to 3. Okay, let's see what you're saying here. No, you would put minus 1 or just... I wouldn't put minus 1. I just put minus, Noah, just to answer that question. Because the 1 is kind of redundant. A 1 is always understood. All right? I'm not saying it's wrong. I'm just saying I wouldn't bother doing that. Yes, Shania, please go ahead. Okay, okay. Thanks for the question. So look at the graph that we're looking at right now. Let me erase some stuff here so it doesn't look too crowded. He says as he makes it even more crowded. So look at that graph, Janaya, and let's just focus on the parts that are above the x-axis. So above the x-axis, hopefully you'll agree, would be this part right here. And then this part right here, again, is above the x-axis, correct? So looking at that, how do we describe that if we're looking at it from the x-axis? Well, I'd say that it's anything to the left of the minus 5, right? Because on the left of the minus 5 is above the x-axis. Well, it's from the minus 5 all the way out to minus infinity. So the way that I would say that is to say minus infinity up to minus 5. So that's the first part right there. And then I would say, oh, does that make sense? Does that make sense? Right. No, it's not. It's not like a coordinate, which is what I think you're thinking. We use the brackets to denote intervals. The brackets are telling us to go from here to here on the x-axis. And then the 0 to 3 is not a point. It says go from 0 to 3 because all of that red section that I just highlighted is also above the x-axis. Okay? So that's what that means. All right, good. You're welcome. Okay, and then the negative part now, right? So maybe I could color code that. Maybe I'll put that in green. Negative part of this function is all of this part right here. And then all of this part over here. So it's anywhere from minus 5 to 0, which is what I put here, and anywhere from 3 to infinity. So once you get past 3 and you keep going, that's where it is negative. Okay. So here's a function down here. Oh, I did write it in. Here's a function down here. And Noah was asking me earlier on whether I would put the minus 1. No, I just put minus. It means the same thing. So minus x plus 5, x minus 3, and x. Okay. All right. So let us move on. This one we got started on. So what you mean is this. It would. One of the things, and thanks for the question, Jeremiah, you're asking about the order in which we write them down. So I'm just repeating that for the recording. So one of the things that we need to remember is that multiplication is what we call commutative. I'll write that big fancy word down. And all commutative all that fancy word means is the order in which you do the operation does not matter. So really what you're doing is you're taking the x, which is at the end, and putting it in the front instead of at the end. And that's because, like I just said, the order doesn't matter. Multiplication, if I multiply 6 by 5, it's the same as multiplying 5 by 6. Commutative just allows us to change the order in which we do something. So addition and subtraction are both commutative, whereas division and, what did I just say? Addition and, well, let me make sure I got that right. Multiplication and addition are both commutative, whereas division and subtraction are not commutative because the order in which you subtract makes a difference. The order in which you divide makes a difference. So to answer your question, putting that x in the front is absolutely fine. There is no rule about that in my book that says that you have to put it in the front or put it at the end. You put it in the middle for all I care, as long as you have all the terms there and as long as the first one is negative. That's really all that matters to me. But thanks for the question. Okay, so then I don't know why I'm doing all this review. I should probably just go straight to the one that we're doing today. But anyway, let's just keep going here. So in this case, what we did is all of this. We said there are these three zeros, one at minus 2, one at 1, and one at 3. We said the 1 at 3 is probably a double zero, an order 2 0. Sometimes we use the term double zero. So instead of putting it as just simply x minus 3, I put x minus 3 squared. Then this is x minus 1 because it means that I'm just simply going through at that x at that part of at that 1. And this is x minus 2, excuse me, x plus 2, which gives us the third 0 there. Excuse me. Now, this does have an a in the front. Whoever answered the question yet about what that a is, and we probably should. Let's take this point here as a potential value of the function. It looks to me that that should be about 0 minus 18. That's what it looks like to me. Okay, so why is it x minus 3 squared? Okay, Joel, let me answer that question for you. Do you notice that there is a 0 in that red circle where it crosses, where it touches the x-axis? Do you see that? Okay, but it's bouncing, isn't it? All right, it's bouncing. So when it's bouncing, it means it's going to be an odd order. So it could be 2, it could be 4. I agree with you. It could be a higher number than 2. It could be a 4, or it could be a 6, or it could be an 8. But let's just assume that it's a 2 for now. And then let's see if we can get the third, one of the points to fit into this is what I'm saying. It is bouncing, Chianti, that's right. Right? So let's now see if we can finish getting the equation of this line by using this point that we see on the line of 0 minus 18. So what does that mean? We're going to get to the positive, negative stuff a little bit later on. That means I'm going to say, using this stop part right here, that y is equal to, but my y is minus 18 now is what we're saying. So minus 18 is equal to the a, which we don't know, x plus 2, and remember it's 0 plus 2 because we're saying plus 2, sorry. So 0 plus 2. Second bracket is going to be 0 minus 1. And the third bracket we agreed on was x minus 3, so 0 minus 3 squared. I think that's what we agreed on. Okay. So, oh, by the way, I just noticed, okay, I think I answered Joel's question already. Joel, are you okay with the answer that we just got, by the way? Do we just assume always? No, we don't assume. You can try it out with the 2 first if it's bouncing, but then if it's not working out for another point, then you can try it with 4, just to answer Riddy's question. All right? And I just want to make sure that Joel is fine with white's x minus 3 squared. Are we clear on that now, Joel? Does that answer work for you? Okay, good. All right, so we'll get to the positive, negative stuff a little later on. Let's just try out this point and see how this works out. So minus 18 is equal to, this looks like a times 2 times minus 1 times. So this side is going to become minus 18a is equal to minus 18. So clearly a is equal to 1. Okay, thank you, Joel. So my equation now is going to become, I don't need to put that 1 in the front. So y equals x plus 2, x minus 1, x minus 3 squared. Because that works for what we're trying to do, right? We're trying to make it have 3 zeros, right? This is minus 1. We're trying to make it have 3 zeros at those 3 points and go through this y-intercept at 0 minus 18. So this is actually working for us. So that's why it makes sense for us to go with 0 minus, so x minus 3 squared, right? Could have been 4, could have been 6, could have been some other even number. But here's the other thing that gives me a clue, by the way. The way it's bouncing on the x-axis like this, if it was a flatter bounce, I would say it could have been a higher number apart from 2. Could have been a 4 or a 6. But it's not really that flat. Right? The flatter it is the higher the exponent tends to be, just letting you know that. So here's our equation. Let's either answer the question now about where is positive and where it is negative. So let me throw that out to the class. And It's about time I got my wheel going. So I'm going to go get my wheel now. All right, so everybody relax. There's nothing to be anxious about when the wheel comes out. It's just a wheel, right? And it just gives me names. And the first thing it gives me is, did I update this list? Hold on, let me just double check something here. Wheel of Fortune. There you go. That's the attitude. Right? Look at it as like something that's like you win something when the wheel picks you. Anyway, Kristen, it's your turn. Kristen, are you with us? Where is Kristen? Yes, I did update my wheel, so I do have all the perfect. Kristen, let's start off with where you think this graph is positive. Let me bring the graph back up for you. Give me the first part of the graph where you think it's positive. From where to where is it positive? And again, if you need help with that, I'm quite happy to give you that help, but let's see if you can think that through first before you ask me for help if you need it. All right. Where is this graph positive? From where to where? The first part of where it's positive. How to exactly tell what degree the function is. All right. So Noah, yes, that's a very good question we should be asking, right? While Kristen is thinking about that, let's go back up to this equation and talk. Actually, the equation is down here. We'll talk about the degree of this function is. I'm going to raise x to the power of 2 in this case. That's going to be the highest power that comes from this. This one is going to give me an x to the power of 1. It's going to give me an x to the power of 1. When I multiply all those x's together, what would you expect that highest power of x to be, Noah? What do you think? Right? So what do you think it is? What power do you think? What's that highest exponent going to be? It's going to be, no, not to the power of 3 at all. It should be 4, because there's a 2 to the power, there's an x to the power of 2 here, there's an x to the power of 1 here, there's another x to the power of 1 here. When you add them all together, it should be 4. Does that make sense, Noah? Right? This is actually a quartic equation, and it kind of looks quartic, right? The end behavior of this function is going from quadrant 2 to quadrant 1. So it actually does look quartic. Okay? All right, great. All right. So we're back with Kristen now. So Kristen, so x less than minus 2. I agree. So the way I'm going to write that, because I like to use the brackets, not that you have to use the brackets, I'm going to use the brackets. I'll put both ways, actually. So first way I'm going to put it is using the brackets, in which case I'm going to say minus infinity. That's a terrible looking infinity. Let's try that again. Minus infinity up to minus 2. Union with. So that's the first part of the answer. Thank you, Kristen. So I agree with that, right? I'm going to get to using inequalities a little later on, but let's just start with that. And let me go now to my next winner. Kristen is out for today, just for today, by the way. And my next winner is Archana. Archana, are you there with us? You are. Perfect. Okay. Can you tell me where else this graph is positive, please? Where else is this graph positive that you can tell? Looking at the graph, where is it positive? From where to where? And you can always ask for help if you need it. Why U? Okay. U is just a union between 1 and positive infinity, you're saying? That is positive? No, no, wouldn't agree with that. Wouldn't agree with that. No, because it has to be positive. Jeremiah, let me hear what you have, and then we'll come back to our channel. Yes, Jeremiah, go ahead. You're going to say what? Okay, well, hang on for a second. Let's see if our channel needs that help, because she may not. So, our channel, do you notice that it stops being positive at a point? Because remember, 0 is not positive. 0 is neither positive nor negative. That's a bit of a clue there for you. So, before somebody else jumps in, just see if you can amend your answer just a little bit. It's not from 1 to infinity, but what? Remember now, when you're touching the x-axis, you're not positive, because when you're touching the x-axis, you're at 0, which is not positive. 0 is neither positive nor negative. So try to amend your answer just a little bit first. Archana, back to you. If you need a hint, I can certainly give you a hint, but let's see what you got first. From 1 to 3. There you go. There you go. You didn't need that help. But we thank Jeremiah for offering it. So it looks like we're saying, Janaya, please go ahead. Sure. By the way, we're not finished yet. Yeah, the answer isn't finished yet, but there's a graph. That's what you're asking for. Okay, yeah. And we're not done yet because that's not the only place the graph is positive. It's positive between 1 and 3, but there's more. There is more. So let me go back. Archana, you're good for today. And let's see if somebody can give us another place where the graph is positive. And that's going to go to Liz, I think is what you said you preferred. So Liz, is Liz there? Elizabeth, are you there? Perfect. Can you tell me where else the graph is positive? Look at the graph and tell me where else is it positive. Where else is it positive? And I'm quite happy to give you help if you need it. Could I have some help? Absolutely. So remember, Elizabeth or Liz, that the graph is positive when it's above the x-axis. So any part of the graph that's above the x-axis, it's positive. Because remember, the x-axis represents where the graph is 0. That's why when it touches the x-axis, it's considered to be a 0. So I'm going to color in all the parts, and hopefully you're going to agree with me, where the graph is above the x-axis. I'm going to color it in let's say, green. I think we agreed on this part right here as being above the x-axis, right, Liz? Does that make sense? That part there is above the x-axis, right? Okay. Here's another part that's above the x-axis. And that's the part that we got earlier on from, I think it was Kristen. But there's another part. You see another part that's above the x-axis, Liz? You see another part above the x-axis? From 3 to where? Up to what point? To infinity. There you go. There you go. Okay, so we union this. I don't know why I'm using green with 3 to infinity. Now notice that I used round brackets everywhere. And that's because when we're talking about positive or negative, where it's actually crossing the x-axis does not count. The zeros do not count. I didn't say where it was greater than or equal to 0, in which case we would change our answer. I'm asking for where it's positive. Positive is either above the x-axis or below the x-axis. Is the union required? Yes, it is, Jeremiah. Yes, it is. Let me show you another way that we can write this answer down. If you don't want to use the brackets, then here's the way that you have to phrase it. You're going to have to say that x is less than minus 2, or, not and, but or, x is less than 3, but greater than 1, or x is greater than 3. So I find that a lot more tedious to show the graph one more time. Yeah, I find it a lot more tedious to draw, to write rather. That's why I just use the brackets. Okay, Kayla, does that help you out? All right. So the union is what the union is saying. Let's put all of these pieces together into our answer. That's what the union is doing. Okay, so we have the negative part of this graph to go to next. All right, and we'll use both terminologies. We'll use the greater than, less than signs, and we'll also use the brackets for those who might find that easier. Okay, so Elizabeth or Liz is out. And the next, I keep using winner rather than victim. The next winner is Janaya. Janaya, are you there? Okay, perfect. Can you tell me where the graph is negative? I'm going to go back up and show you the graph again. Can you tell me where this graph is negative? From where to where is this graph negative? Absolutely. Anywhere else? That's it. Yeah, -2 and +1 is correct. So I'm going to put that as -2 up to 1. But for those of you who like the other method, then I'm going to use this. X is less than 1, greater than -2. I'm not using less than or equal to. I only have to use less than. All right, just so that we're clear. Can you show me the graph? Okay, so I think I did that already. Yes, Janaya, please go ahead. Yeah, comma is so it's not and I know some people are thinking it looks a lot like a coordinate. It's not meant to look like a coordinate. I mean, I know coordinates are written the same way, but what this is saying is I'm going from the interval that I'm denoting is from -2 to 1. So that's what that terminology means. It goes from -2 to 1. Why don't we consider 0 when it passes the y-axis? Okay, so let's talk about that. Kianta is asking. Why do we have to use union? Rachel is saying. The union is only used when you're adding different intervals together, right? So it's saying it's this piece and also this, and sorry, or I should say, because and means something else, or this piece or this piece. So all three have to be joined together to give you the full solution, Rachel, just so you know. And why don't we consider 0 when it passes the y-axis? Okay, so let's answer that question. We're asking for this. Let's just do where the graph is positive. Let's just talk about where it's positive for a second. So positive means, Keante, that you're above the x-axis, correct? Let's just first of all accept that. Keante means above the x-axis. So when you're on the x-axis, are you above it? You're right on it. Are you above it when you're on it? You're not, are you? So above just means you have to, it's just after you pass that point that you're above it. But when you're actually on the x-axis, you're neither above nor below. That's why it's neither positive nor negative. Now, there's a different question that you could ask, which is, where is the graph greater than or equal to 0? That's a different question because now you're not just saying when are you above the x-axis, but you're also saying when you're on the x-axis because you said or greater than or equal to 0. So that would be a different kind of question to answer, which we'll answer another time. Okay, let's move on. And I appreciate every one of those questions. I really do. Right? So thank you for all of those questions. Let's move on. We're going to sketch this graph now, but we're going to do a little bit more than just sketch the graph. We're going to answer some questions about the graph first. We're going to get the degree of the graph, the leading coefficient, the end behavior, the zeros, and the y-intercept. All right? So before we sketch the graph, we're going to answer all of those questions. Okay, let's start off with let me show you again the table. Let's start off with the degree of the function. If I'm multiplying the three brackets together like that, right? I'm not going to the wheel, I'm just sort of talking generally to everybody. If I'm multiplying these three brackets together, there's an x to the power of 1 in this bracket, an x to the power of 1 in this bracket, an x to the power of 1 in this bracket. My question is, what would you expect the degree of this function to be? Yes, Jeremiah. And Emily and some other people. Go ahead. So you're going to agree with them then? You're going to agree with all those people? You really think they're right? Okay. And they are. They are. So if I ever asked you the question, if I showed you this function and said, what's the degree of the function? The answer would be a degree 3. What is the lead coefficient? Let's go back up to the function again. Okay. You can put your answer in the chat as well, or put your hand up and ask. But what would you think is the lead coefficient of this function? Look at the three brackets that you're multiplying, right? And as I said, what's the coefficient in each one of those brackets? And yes, the answer would be the lead coefficient. No, it's not. No, it's not -6. No, it would be the coefficient of this x, the coefficient of that x, and the coefficient of that x, all three which have a coefficient of 1 being multiplied together. Okay? So it would still be 1. So it's 1 times 1 times 1. The lead coefficient is 1. So we have the degree, okay, and we have the lead coefficient. That could give us an idea of the end behavior, right? We've talked about this whole end behavior thing before. What would you suggest would be the end behavior for a function that has a degree of 3 and a lead coefficient of 1? Remember, you talk about Q this and Q that. So what quadrant to what quadrant would you expect for a degree 3 which is an odd number, by the way, and a lead coefficient of 1, which is a positive number. So Emily's thinking Q3 to 1. Harish is saying the same thing. Axel is saying the same thing. Okay, good. So clearly, most of you, all of you, seem to be on the right page. It's a Q3 to Q1. All right. The zeros. So let me start getting more specific now. I'm looking for, so Janaya was the last person. I'm looking for, don't put anything in the chat right now. I'm looking for the zeros and the order of those zeros. Is it an order 1, 2, 3, 4, 5, etc., etc.? And that question is going to go to Harish. Harish, I'm going to ask you to look at the equation and see if you can tell what the zeros are and what the order is for each of those zeros. Is it order 1, 2, 3, 4, 5? What was the order of those zeros? So Harish, are you there? Where's Harish? Perfect. Harish, give me one of the zeros and the order of that zero, please. Any zero you can think of from the equation. The equation tells you kind of what the zeros are. Give me, so 1, 0 is an order 1. Good. So hold off. Don't tell me anything. I'm going to put that down here. So 1, 0, which is an order. Oh, sorry. Order 1. Good. Thank you very much, Harish. I'm going to ask somebody else for another one of the zeros. Harish, you're good for today. I need another one of those zeros and the order of that zero. And I'm going to go to, this looks like Aliza. Aliza, your time. Are you there? Aliza, where are you? Where is Aliza? Okay, I don't see Aliza in the room. Was it that she was absent today? Did I mark her absent? I don't remember. Let's see. Harish, Aliza was marked absent. Okay, sorry. I'll take her out for today then. So the question I'm going to be asking of the next person is another zero and the order of that zero. That goes to Karis. Karis, are you there, Karis? Perfect. Can you give me another zero, please, and its order? Oh, I need to show you the equation, don't I? There's the equation. Give me another zero and its order. And as usual, if you need help, you ask for it. No problem whatsoever. So the zero would be minus 2. And what's the order of that zero? Order 1, 2, 3, 4. What is the order of the zero? The order would be 1. Okay, with a question sign. So you're not absolutely sure, but you're right. So it's minus 2, 0, which is an order 1 as well. Good stuff. How do you find the order again? Can anybody help me out with that? Rachel is asking, how do we find the order? Can anybody jump in on that, please? Jeremiah, please go ahead. Thank you very much. Thank you very much, Jeremiah. So does that help you out, Rachel? Does that make sense? Okay, perfect. Okay, so we've had 2 zeros so far, one at 1, one at minus 2, but there is a third 0, and we need to know what that is. So Karis is out. Was that Karis just now before? Yes, it was. So let's get the next person in to give us that third 0 and also its order. And you just heard the explanation for that. And that goes to Emily. Emily, are you there? Perfect. Emily, can you give me the next 0, please? I can scroll back up to the graph to help you out with that. What's the next 0 and its order? So minus 3, order 1. Perfect. So they're all order 1 zeros. So minus 3, and it's an order 1. So that answers all of this stuff here. This whole thing here was answered by that. Let's get to the y-intercept now. Can anybody remind me? I'm not going to the wheel for this. Can you remind me how I get the y-intercept of a function if I have its equation? Any ideas as to how I might get that y-intercept? Any ideas on that? because that's going to help me to draw the function as well. Set your x to 0. There you go. Set x to 0. So I set the x to 0. It's going to be y equals 0 minus 1, which is minus 1, 0 plus 2, which is 2, and 0 plus 3, which is 3, and that's equal to minus 6. I think we can all agree on that. So I know a few things about this graph, which means I can sketch it. I know that it has 3 zeros which are not bouncing zeros. I'm going to go straight through with these zeros. 1 at 1, minus 2, and 3. So 1, minus 2, and 3. 1, minus 2, and 3. Those are my 3 zeros. Oh, minus 3, sorry. So let's erase that one. So those are my 3 zeros. I also know it's going to cross the x-axis, sorry, the y-axis at minus 6. And I know one more thing that's going to help me out. The end behavior is that it goes from quadrant 3 to quadrant 1. So I need to start out somewhere down here, go up through this one, come back down through this one, and come back up looking something like that. Arrows on the two ends. There is my sketch. I don't need Desmos for that, right? I follow the traits of the function. I know that it goes from 3 to 1. I know it has 3 zeros. I know there are order ones. It goes straight through. I know there is a y-intercept at minus 6. Do I know where this max point is up here? Right? Do I know where this is? No, I don't. Do I know where this min point is? I don't. Right? You need calculus for that. So those of you who have signed up for calculus, there are the tools that you can use to get those max and min points. But right now, I just have the general shape of the graph. It's going from 3 to 1. It crosses those x-intercepts. It crosses that y-intercept. And there you go. So I can draw a pretty decent graph with that information. And that's what I'm going to be asking you to do, right? Without the aid of any graphing application, to be able to draw a graph based on what you see from the equation. Okay, let's keep going here. Unless there are any questions on this, we're going to keep going. Let's look at this one. Sketch a graph of the following polynomial. All right, so let's go through all the things that we asked before. The degree, the lead coefficient, the end behavior, the zeros, and what kind of zeros they are, and the y-intercept. Okay, so we've done this before, so that should help you out, right? We've gone through all of those things before. So I think I should confidently be able to, if that was Emily the last time, I should be able to pick anybody out and get them to help me out with this. So it looks like that person is going to be Nicholas. Okay, I see a hand going up. Let me see who that is. Okay, it looks like it's more than one person. Jeremiah, please go ahead. If it's an answer, Jeremiah, we're just looking for, you're not going to answer the question here because I saw your hand up. Jeremiah, go ahead. Okay. No, you don't. No, you don't, because you don't have enough tools yet to find those max and min points. When you get to calculus, you will have those tools. Okay, so for now, all you're doing is just getting the general shape of the graph with intercepts and that kind of thing. We'll talk about asymptotes and all those things with irrational functions, but no, we don't. I'm not requiring you to know where the graph is. Actually, there is one section when we're doing, let me take that back. When we're doing rational functions later on, there's a point, because the reciprocal of a quadratic function is also symmetrical, then yes, there's a point at which you will need to know where the maximum point is, but we'll get to that. But for right now, for these functions, no, we're not requiring you to be able to do that. Okay, but great question. Person that gets the prize is Ava. Ava, are you with us? Perfect. So Ava, looking at what you're seeing now, what would you say is the degree of this function? What would be your best guess as the degree of this function? Well, I wouldn't say guess. You probably should be able to say it with some certainty. What's the degree of this function? 2? No. Can I give you a little bit of a hint with that? So you're multiplying two brackets, right, Ava? Right? Yes? We're multiplying. Okay, the first bracket is going to have an x squared term come out of it. Would you agree with that? When you work this bracket out, when you multiply it out, you're going to get an x squared term out of that. Okay. The second bracket is going to have an x to the power of 1 out of that one as well, correct? Right? Because there's no exponent on this one, but you can assume an exponent is a 1. All right? So far, so good, Eva? Okay. So really, let's go back and think of exponents now. So I'm going to have an x squared in one. I'm going to have an x in the other. I'm going to be multiplying them. Remember that when you are multiplying things that have the same base, you add the exponents. Remember that? So you tell me now what the degree of this should be. Should be 3. Thank you very much. Well done, Eva. And sometimes that little help that I give you is what will get you there, and that's fine, right? And anybody who needs that help, you just ask, and that's why I'm here. Okay, so we got the degree of the function. Thanks to Eva. We'll take her out for today. My wheel is getting kind of skinny now. There's a lot less people in there. But one of those people that's in there is Rachel. Rachel, are you with us? Rachel, there you go. Perfect. Okay, Rachel, the next question for this graph is the lead coefficient. So I want you to think now, right? Let me erase this part right here. To get the lead coefficient, I'll give you a clue. I mean, I don't know if you want to answer first or you want the clue, or you think you can answer right away. Do you think you know what the answer is before I give you a bit of a clue? You think that's you are right, by the way, that it is minus 2 because this function has a 1 in it. Oh, sorry. So there'll be 1, that's the coefficient, sorry. There's a coefficient of 1 in this one, a coefficient of 1 in that one, and a coefficient on the outside of minus 2. So it means that when you multiply all three things together, the lead coefficient is in fact minus 2. So let's give Rachel that answer. Yes, she's absolutely right. Is anybody not clear on that? Is there anybody who wants me to go over that some more? Does that make sense? Okay. In behavior. So now that we talked about the degree, and we see what the degree is, and we've talked about the lead coefficient, we know what the sign of that is, that should tell us what the end behavior is. I'm taking Rachel, by the way, and we're spinning again. And this time, the name that comes up is Jeremiah. Jeremiah, it's your turn. From Q2 to Q4. So we're thinking third degree. So it's an odd number. Negative lead coefficient should be going from Q2 to Q4 is absolutely correct. Well done. Well done. Okay. Everybody clear on that? That makes sense to everybody. Let me take Jeremiah out for today. We're going to be thinking about the zeros now and what kind of zeros they are, or the 1, or the 2, or the 3, that kind of thing. And that's going to be the task, the first one anyway, for Joel. Joel, your time. Joel, are you there? Joel, can you give me the first 0? Let me take you back up to the function. What 0 do you see and what kind of order does it have? Remember Jeremiah was explaining that to us earlier on. Give me some zeros and their order, any one of them. So you have a 0 at 1, which is an order 2. Well done. So 1, 0 is a 0, and it's an order 2. Okay, thank you very much, Joel. Joel is out. And I'm going to be asking for the other 0 because there are actually 2 zeros there. And the other one goes to Keontae. Keontae, your time. Step up, Keontae. Are you there, Keontae? Perfect. Give me the other 0, please. Let me take you back up to the equation. What's the other 0 that you can see there? The other 0 would be a minus 2 or the 1. Well done. Minus 2, 0, order 1. So those are my 2 zeros. That answers this question right here. Okay, we're rolling along. We still have to get one more thing here for us to draw this, and that's the y-intercept. and Keontae is out. And we did y-intercept before, so I should be able to ask anybody for an answer. And the anybody is, or the person I should say, is Axa. Axa, are you there? Yeah, perfect. Axa, let me take you back up to the equation. Where would you say this y-intercept is? Right, remember what we did the last time was to plug in 0 for x. Remember that? Okay, so it's over to you now. What would you think is the y-intercept on this one? When I put 0 into this function, when you put when you put 0 into this function, what are you getting? If you need help as usual, just tell me, and I'm quite happy to help you out. -4, she says. Really? Is that your answer, Axa? -4? You confident about that? I don't see any question sign there like you think you really know. You sure it's -4? No, she's beginning to doubt now. She's Folks, I do that all the time. I will challenge you on your answer, not because it's wrong, but because I want you to think about it. And if you think you're right, you just say yes. So it is -4. Absolutely. All right. So everybody good with those answers so far? All right. So what we're going to do is we're going to plug in those numbers into our graph and try to sketch it. It has a certain end behavior. We know that it has these x-intercepts, that y-intercept. We should be able to come up with a reasonable sketch for this function. So here we go. My x-intercepts, let me go back again, are at 1 and -2. 1 and -2. So 1 and -2. But they both don't behave the same. Oh, and by the way, my y-intercept we said was at -4. But they don't all behave the same way, right? We said that one of the zeros was an order 2, which means this is a bouncing 0. This one bounces, the 1. This one does not. It just goes straight through. So 1 bounces at 1. 1 does not bounce at -2. So here's what I'm going to say. Remember, it goes from 2 to 4. That's what Jeremiah told us. It goes from 2 to 4. So I'm going to start at 2 up here. I'm going to come down through here. I'm going to come up through here. I'm going to bounce here and come back down. There's my 2 to 4. Just checking here. You add all exponents to find the degree, right? Yeah, yeah, that's really what you're doing. Yeah, because this is 2 here and this is 1 here. So yes, you add all the exponents, Isaac, to get your degree. Absolutely. Okay. Now, I know my graph is not very pretty, right? And that wasn't my aim, but it does satisfy all of the requirements that I needed. It has the right end behavior. It has the right intercepts. The zeros behave the way we expect them to behave. It goes straight through where it's supposed to go straight through. It bounces where it's supposed to bounce. It has the right y-intercept. So everything checks out. I check all the boxes as I go through putting this together. Let's try to do, I think there is one more left. I believe, let me just see. Actually, 2 more left. Oh, well, one is just to get the equation. Okay, now be careful about this one. This one has a little bit of a, we'll see. We'll see how this goes. We'll see how this goes. All right, let me go back now. And Axel was the last person. I want you to start thinking about the degree of this function. The degree of this function. So Kale, are you there? Perfect. So Kale, let's have a look at the equation. And let's try to think now about what the degree of this might be. What do you say, Kale? What would you suggest is the degree of this function? Without me saying anything at all, if you do need me to say anything, then fine. But without me saying anything, what would you guess is the degree of this function? What would your guess be? 7. Okay. Are you confident about that 7 though? You want to stand behind that 7? What do you think? I want you to think about that. Remember how we got the degree before? Do you think that 7 is going to hold up? Do you think I'm going to say that that's right? What do you think? Well, you're changing it to 4. Okay. So which of your answers are you confident about? The 7 or the 4? I'm not sure now. Because I see you're changing your vote on me. You're changing midstream on me. So I need to know. Can you please explain how you get the degree before? Okay, all right. You're going to add up the exponents. Add up the degrees of each of the exponents that are there. This bracket here is going to end up with an x to the power of 3 in it. This bracket here is going to end up with an x to the power of 1 in it. Can we agree on that, Kayla? Right? The highest power that comes out of the first bracket is going to be an x to the power of 3. The highest power that comes out of this one is going to be an x to the power of 1. So 4 is correct. Yes, 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 yes. So the degree is a degree 4. Okay. Thank you, Kayla. All right. The other question is, take out Kayla. We only have about 7 or 8 people left in my wheel now. My wheel is getting really, really skinny. Rylan, are you there, Rylan? Perfect. Rylan, let me be careful with you now on this one. I'm asking for the leading coefficient. Now, I don't know if you want to sort of give me an answer, or do you want me to give you a little bit of a you want to just give an answer, is what you're saying? Are you ready with that answer? Or you think the answer is -1? Okay. I'm gonna have to say no to that. No, it's not -1. I want you to think about it this way, Riley. This first bracket here, let me erase the second one. This first bracket here, you're gonna have a 2x in it being raised to the power of 3, right? Both terms are going to be raised to the power of 3, but this 2x is going to be raised to the power, and that's where your leading coefficient is going to come from. And then you're going to multiply that by an x, a 1x to the power of 1. Then you're going to multiply all of that at the end by a -1, but there's a minus in the front. Okay, so it's quite a bit. I mean, it's a more challenging lead coefficient than all the other ones that we've done so far. It's not just a number in the front of the bracket. It's not. Because you have to think, what happens to this 2? That 2 is going to be raised to the power of 3. That's going to be part of your lead coefficient. This x is going to be raised to the power of 1. I mean, there's nothing here, so we assume it to be a 1. So we're going to take the coefficient from the first bracket, times the coefficient from the second bracket, times the coefficient from in front of everything to get our overall coefficient. So try to give me a different number, because the answer that you gave me before isn't right, but try to think of what it might be if we approached it that way. Think about this being multiplied by this, being multiplied by essentially a -1 at the end. And let's see if we get a different answer, because the first answer wasn't quite right. I don't want anybody else to give an answer. Please, just hold on. Let's see if we can get this from Rylan. Rylan, think about what that 2, just being 2x, that 2x in the first bracket, when you raise that to the power of 3. Well, in fact, let's do this. Let's do this, Rylan. Let's take the 2x and raise that to the power of 3. What does that give you? Give me what that is. What's the result of raising 2x to the power of 3? And by the way, both things have to be raised to the power of 3. What do you get at the end of that? 2x to the power of 3. Everybody else, just hold your fire, please. Just hold on and be patient. Raise that whole thing to the power of 3. So what that means, Rylan, is that both things inside must be raised to the power of 3. Okay? You tell me what you get when you do that. Okay, so is your final answer -8, or because the 2, okay, just let me be clear. The 2x to the power of 3 is going to give you 8x cubed. Just let me be clear on that. But then that 8 gets multiplied by this 1 and gets multiplied by this minus in the front as well. So yes, your answer is going to be -8, but it's at the very end that you get the -8. But just the 2x to the power of 3 on its own gives us 8x cubed. Just want to be clear on that. But that 8 gets multiplied by this 1, and it's multiplied by that -1 on the end. So yes, the answer is a lead coefficient of -8. Okay, so I just want to make sure everybody's okay with that -8. That -8 comes from multiplying a couple of things together. It comes from multiplying the 2x cubed by the 1x to the 1 times the -1 in the front. That's where that -8 comes from. Okay, thank you very much, Rylan. Let's get to end behavior now. With all that information that we just came up with, That's going to give us a particular end behavior. Nobody put any answers in the chat, please. Just wait. Because who I want to ask right now is Neil. Neil, are you there, Neil? Is Neil with us? Perfect, Neil. Can you give me end behavior based on that information? Degree 4, lead coefficient of -8. Go. I want you to think this through, Neil, because when we come back tomorrow, I'm going to be coming back to you to ask you the same question. All right? You don't need to apologize. I just want you to go back through the first day video, watch that again, and make sure when you come in tomorrow, you're ready for us, okay?